Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. I have brought a series for ISI and CMI preparation. In fact, my today's session, which is based on few good binomial coefficient problems, is also relevant to JEE Advanced. Okay, so this is my first question. Please see how we can do this. I have two methods to solve this. I think we can write this as summation minus 1 raised to the power r minus 1 NC r, and here it will be 1 plus 1 by 2 and so on plus 1 by r, and r will start from 1 going till n. Okay, now I think we can write this also as summation r is equal to 1 to n minus 1 raised to the power r minus 1 NCR, and this I can write as integration 0 to 1 plus x and so on plus x raised to the power r minus 1 dx. Okay, now summation and integration, they both do same thing, summation. So even if I interchange their positions, this entire sum will not change. So I will write this as integration 0 to 1 summation minus 1 raised to the power r minus 1 NCR, and this thing can be written as 1 minus x power r, which is actually sum of r terms of a GP into dx. Now I will here r is taken from 1 to n, but you can notice here that even if I put r is equal to 0, corresponding to r is equal to 0, this will be 0 only. So even if I write this summation, sigma summation, starting from r is equal to 0 to n, then summation will not change. But here I will also, I will also split these two summations like this, dx upon 1 minus x, and then plus I will write 0 to 1. Actually this minus I have put into this minus 1, so this minus 1 power after summation r is equal to 0 to n, this will become minus 1 raised to the power r and x power r NCR upon 1 minus x dx. Here you can check summation of this thing, because this thing is independent of x. So even if I take this common out, this integration sign, this integration will not change. But you can see it is just the property of NC0 minus NC1 and so on. So this will become 0. Whereas this integral here you can check, it will be summation. This summation actually will become, please check, if I notice at this summation, it will be just 1 minus x raised to the power n. The binomial expansion of this 1 minus x raised to the power n will be this thing only. So here I just have to integrate this. Let me use this space. So here I will be integrating 1 minus x raised to the power n minus 1 dx. So its integration becomes 1 minus x whole raised to the power n upon n, and there will be additional minus sign here, and limit will be from 0 to 1. If you put 1, we get 0. If we put 0, then we will get minus 1 upon n actually. So the answer is 1 by n. So comparing with this, we get lambda to be equal to 1. So this is how this can be solved. But I have one more method to do the same question. Please see how. I can write this first term as n minus 1 C0 plus n minus 1 C1 using that property of NCR plus NCR plus 1 is equal to n plus 1 CR plus 1. And then the second term 1 plus 1 by 2, I can write this as n minus 1 C1 plus n minus 1 C2. Okay, and then next one would be 1 plus 1 by 2 plus 1 by 3, and this NC3 I can write as n minus 1 C2 plus n minus 1 C3. Okay, and so on we can write. Last term I think I'll write just like this only, because NCN is 1 only, we cannot split it. So it will be 1 plus 1 by 2 plus 1 by 3 and so on 1 by n NC, or let me write n minus 1 c n minus 1 here. Now please notice one very important thing here. N minus 1 c0, if you see there is only one term, so I will write this as 1 into n minus 1 c0, whereas n minus 1 c1 is coming at two places. So this 1 will be cancelled here, so we get 1 minus half n minus 1 c1, and then 1 by 3 n minus 1 c 2, then minus 1 by 4 n minus 1 c3, and so on. In fact, the second last term will also be cancelling all the terms of this bracket except this 1 upon n, and we will be having minus 1 raised to the power n minus 1, n minus 1, c n minus 1, and upon 1 by n. So you can check, this becomes actually summation of minus 1 raised to the power r n minus 1 cr upon I think r plus 1, where r is starting from 0 and going till n minus 1. So I can write this expression minus 1 raised to the power n, this as n c r plus 1 upon n. It is just simple modification. R is equal to 0 to n minus 1. So you can notice that if I start putting r is equal to 0 and so on, so it will be nc1 first, then minus nc2, then plus nc3, and so on, then minus sign here, and then so on, and it will be going till, you know, last whatever it is, minus 1 raised to the power n minus 1 nc n, and whole divided by n. So you can see it is actually summation of all in alternate positive negative terms, but there is first term missing. So first term, if I write nc0, but I have to write this with minus sign, then only they all will be plus minus plus minus. For that I have to add nc0 here. So you can see this bracket will become 0 and my answer will be 1 by n. So same thing we are getting from this method also, and lambda becomes equal to 1. Okay, so now coming to this question number 2, in which we are asked to find r is equal to 1 to 2n minus 1 into minus 1 raised to the power r minus 1 into 1 upon 2n cr. For this, I will first like to tell you one important result, that is 1 upon ncr plus 1 upon ncr minus 1 if I have to solve. And if we take LCM, we get ncr into ncr minus 1, whereas in the numerator you will get n plus 1 cr. If we simplify it, you will get n plus 1 factorial upon r factorial, n plus 1 minus r factorial, whole divided by, this will be n factorial upon r factorial, n minus r factorial. And here also n factorial upon r minus 1 factorial into n minus r plus 1 factorial. So you can check, this will get cancelled, and this r factorial will get cancelled. N factorial will also cancel this n plus 1 times. In fact, after simplification, I can write this as n plus 1 upon n, and denominator I will write n minus 1 factorial, and these two terms n minus r factorial into r minus 1 factorial. So you can see we are getting n plus 1 upon n into 1 upon n minus 1 cr minus 1. Okay, so let me write this result separately here, that 1 upon, let me write n minus 1 cr minus 1 here. This will be equal to n upon n plus 1 into 1 upon ncr plus 1 upon ncr minus 1. Okay, this is what we will get. Okay, now I am going to use this result here also. You can write first term as 1 upon 2nc1, then minus sign, 1 upon 2nc2 plus 1 upon 2nc3, and so on. The last term will come with plus sign because r is going up to 2n minus 1. So 1 upon 2nc2n minus 1. Now, if I use this result, so this n upon n plus 1 will be a fixed number because it is independent of r. It depends only upon this n minus 1. So here, because I am having 2n, 2n, 2n everywhere, so it will be 2n plus 1 upon 2n plus 2. I can take this as common, and my first term now will be 1 upon 2n plus 1 c1 plus 1 upon 2n plus 1 c2. For r minus 1, we were having r and r minus 1. So for 1, we will have 1 and 2. Then minus sign. The next term would be 1 upon 2n c2, 2n plus 1 c2 plus 1 upon 2n plus 1 c3. And then plus sign 1 upon 2n plus 1 c3 plus 1 upon 2n plus 1 c4. And so on. There will be minus sign here, and then in the end you can see it will be 1 upon 2n plus 1 c, it was 2n minus 1, so here it will be 2n minus 1 plus 1 upon 2n plus 1 c2n. Now you can see there is some cancellation going on, like this term will be cancelled with this term will be cancelled with this, and so on. So what will be left, because it's a VN method and you can see every alternate term is getting cancelled. So my first bracket, if I'm getting this 1 upon 2n plus 1 c1, which I can write 1 upon 2n plus 1. So here also this last term will be remaining. This will also get cancelled with one of the previous terms. Okay, and the value of this also is 1 upon 2n plus 1. So if you simplify it, we get 1 upon, we are getting 1 upon n plus 1. We are getting 1 upon n plus 1. Because this 2n plus 1 will be cancelled and 2 will cancel 2n plus 2. So this will be the answer of this question. Okay. Now coming to this question number 3. If you look at this expression here, we are getting n plus 2 c0 2 raised to the power n minus 1. Here this nc0 is written as c0 only. So all these terms c0, c1, they are actually nc0, nc1, etc. So what you can see, this n plus 2 is multiplied with this 2 power n minus 1. So this term is having one more value than this power. Same with here also, same here also. Okay. Now, if I have to do this question, let me just try with the expansion of x plus 1 raised to the power n. X plus 1 raised to the power n, which is nc0 into x power n plus nc1 into x power n minus 1 and so on, plus ncn into 1. Okay. Now please see, if I put x is equal to minus 2, then alternate positive negative will be taken care of. Okay, or maybe what I can do, I can put minus sign here. Okay, then we will get alternate positive negative automatically here. We can write minus here, then plus, and then so on. Here it will be minus 1 raised to the power, I think it will be minus 1 raised to the power n. Yeah, when n is odd, it is minus. When n is even, then it is plus. So this is how we can do it. But how to get these kind of terms? Maybe this power should multiply here. But even if I try to do the differentiation and I multiply with this power here, okay, you can see we will not get n plus 2. To get n plus 2, maybe what we can do, we can multiply by x square here, multiply by x square here, and then all the powers of x will be raised by 2. So nc0 into x power n plus 2, then minus nc1 into x to the power n plus 1 and so on, plus minus 1 raised to the power n ncn into x power 2. Now if I do the differentiation and I put x is equal to 2, I think we will be able to get what exactly is asked here, isn't it? So differentiate and put x is equal to 2. So if I differentiate left side, we will get 2x into x minus 1 power n plus x square into n x minus 1 power n minus 1, where I will put x is equal to 2, and that is the required expression in the question. So what we will get, if I put x is equal to 2 here, it will be 4, this will become 1 only, plus this will be 4n. So answer for this will be D, 4 into 1 plus n. Now coming to this question, here we are given the expression as 20C0 into 20C2 plus 20C2 into 20C4, then 20C4 into 20C6, and so on. In the last it will be 20C18 into 20C, this will be 20 here. Okay, now please see, I can also write this as 20C0 into 20C18 so that some of the numbers below it are same. 20C16, and that's very standard problem if sum is same. In fact, for difference also it could have been done directly, but let me do it for sum only. Okay, so this is how we can write it. Now this question can be done directly by methods of PNC. If we would have 20C0, 20C18, then 20C1, 20C17, you can check all terms are not there, only even numbers are written below it. If it would have been all the terms, then this question would be directly 20 boys, 20 girls, and we have to choose 18 persons. So either 20 boys, 18 girls, 1 boy, 17 girls, and so on. So all possible ways, and answer will be directly 40C18. But here, because those numbers are missing with odd number written below it, so it cannot be done that way. So what we will do, we will now actually write this as coefficient of x raised to the power 18 in, please see, I will write 1 plus x whole raised to the power 20 into 1 plus x whole raised to the power 20. So if you multiply these two brackets and try to check the coefficient of x power 18, please check what we will get. First we will get 20C0 getting multiplied with 20C18, but then 20C1 will also be multiplied with 20C17. So there is the same problem here also. Then what to do? I think we need to get rid of these odd number of terms. This can be done if I add 1 plus x raised to the power 20 into 1 minus x raised to the power 20 to it. And you can check. In this one, what we will get? My first term will be 20C0 and 20C18 will be multiplied, and x power 18 being even power, there will be plus sign, but in the next term we will get minus sign. So 20C1 into 20C17 and so on. So you can check in these two brackets, these terms will be with same sign, but these terms will be with opposite sign, hence they will get cancelled. But these will become 2 times, so I have to write 1 by 2 also here. So now it is just a standard problem that I have to find the coefficient of x power 18 in 1 by 2 into 1 plus x raised to the power 40 plus 1 minus x square whole raised to the power 20. Okay, and this is direct, it will be 1 by 2 40C18 minus 20C9. Actually, x power 18 in this will come when you raise x square by power 9, and 9 being odd, so there will be minus sign here. But actually they are looking for 39 and 19, that too with 21 and 10. It can be taken, it can be done if I write this as 1 by 2 here, 40C22 I can write, and 20C11 I can write, and then I will take 40 by 22 common from first one, and then it will be 39C21, and here I will take 20 upon 11 common, then it will be 19C10 here. So 20 by 11, 40 by 22, they both are same thing. We can take common. So we will get 10 upon 11 into same thing. 39 C21 minus 19 C10. So here my A will be nothing but 10. My A will be here 10. Okay, they are looking for XY as 40. Total number of ordered pair solutions XY, where XY belongs to I plus. So basically we need to find the factors. We need to find the factors. 40 being 2 power, I think 3 into 5 power 1. So number of factors will be here. You can check 4 into 2, that is 8. Okay, so let me check. If I write one of the factor as x, the other would be, the other y will be fixed because their product has to be 40. So I think there will be 8 ways. Yeah, if I write all the factors of 40 in increasing order and I give that value as to x, y will be automatically fixed and it will take care of all possible ordered pairs. So answer here will be 8. Yeah, this is the answer. Now coming to this question in which we are asked the value of summation of product of two binomial coefficient. Here we are given, first term I can write as 20C20 into again 20C10 plus I will write this as 21C20 into 19C10, then 22C20 and 19, it will be 18 C10 and so on. And the last one would be 30C20 and 10C10. Okay, now there's one very good idea, one great idea you can say, which will make this question direct. How we can do that, please see. You can see the sum of numbers written here are same everywhere. Okay, so what I'm going to do, I will assume there are two sets of beggars. If you remember beggar coin method, in which we distribute identical coins to beggars, and the formula for the same is n plus r minus 1 cr minus 1, in which n identical coins are distributed among r beggars. And the condition here is that no beggar can force you to give any one or two or three coins. You can choose to give all coins to any beggar. Only other condition is that you have to distribute all the coins. Okay. Now here please see what I am going to do. I will assume there are two group of beggars. One group is having 21 beggars and other group is having 11 beggars. Okay, and number of coins are total 0 plus 10, 10. 10 coins, total coins are 10, and I am assuming there are two group of beggars, one is 21, one is 11. Now, what I can do, I can give 0 coins to this group and then 10 coins to this group, and you can check this will be done in this number of ways. The formula is n plus r minus 1 cr minus 1. So n will be 0, r is 21, so 20c 20, whereas in this case n will be 10. So 10 plus 11 minus 1 is 20 and r minus 1 will be 10. Or you can give 1 coin to this group and 9 coin to the other group. And you can check, this will give you the second term here. 1 coin going to 21 beggars, it will be done in 21 plus 1 minus 1, so 21c 20 ways. Same way, 9 coins will be given to 11 beggars in 11 plus 9 minus 1, 19c 10 ways. And similarly, if you give 2 here, 8 here and so on, in the end you will give 10, all 10 coins to this first group and 0 coins to this last group, which will be getting to this. Now, as you can see, we have considered all possible scenarios. So isn't it like that we club all the beggars together? Okay, so my R now will be equal to 32. and number of coins are 10. So distributing 10 coins among 32 beggars, it will be done in how many ways? I think 41C 31 ways. Okay, so 41C 31 will be the answer, or maybe they can write this as 41C 10 also. So there will be two answers, B and C, for this question. So this way this question becomes too easy, isn't it? Now coming to this question number 6, which says if PR is the coefficient of x power r in this expansion, then we have to find the value of PR and P4. Okay, now to do this question, please listen carefully. We can write this 1 plus x square into 1 plus x by 2 whole square, 1 plus x upon 2 square whole square, and so on, as 1 will be the first term. In fact, P0 can be equal to 1 because constant term will be when all ones are multiplied, plus I will write P1 into x, then P2 into x, and so on. Okay, now please listen carefully. If I combine all these brackets except the first one, if I take all these brackets, you can see we can think of that my first bracket here was having 1 plus x. Now here it is having 1 plus x by 2. My second bracket here was having 1 plus x by 2, whereas here it is having 1 plus x upon 2 square. So I can think of as if I have replaced the x by 2 in all these brackets. So if that is so, then the expansion of the product of these brackets will also be the same thing. I can write this as 1 plus P1 into x by 2 plus P2, here it will be x square, P2 into x square by 4, and so on. In fact, as I have to find the relation between PR and PR minus 1 and PR minus 2, okay, let us write this as up to infinity, and this will be equal to 1 plus P1x plus P2x square, and so on. Here I can multiply, I can open this bracket 1 plus 2x plus x square, and now I will write the terms which are of our use, and they are actually PR minus 2, which will be multiplied with x power r minus 2 upon 2 raised to the power r minus 2, then p raised to the power r minus 1 upon 2 raised to the power r minus 1 into x raised to the power r minus 1, and then PR upon 2 raised to the power r into x power r, and so on. This will also go up to infinity. And same way, right hand side 1 plus P1x, and so on. I will write just PR into x power r, and so on. Now we will compare the coefficient of x power r both sides. On the left hand side, we will get x power r if we multiply this one with this term here. So we will get PR upon 2 power r, whereas this 2x will be multiplied with this. So we will get PR minus 1, and upon it will be 2 power r minus 2. Then x square will be multiplied with this. So we will get PR minus 2 upon 2 power r minus 2. On the right hand side, it will be just PR. Okay, now we can keep PR term on one side. So 1 minus 1 upon 2 power r, and this will be equal to PR minus 1 plus PR minus 2 whole divided by 2 power r minus 2. So you can check, we are getting exactly same relation as given in the option number A, because this 2 power r minus 1 will go down and 2 power r will be multiplied up, and this will cancel 2 power r minus 2 4 times. So A is the answer. Now to get P4, what we will do, we have already found P0 as 1, whereas to find P1, that is the coefficient of x. Okay, what we can do, you can write this as 1 plus 2x plus x square. Similarly, other bracket, the coefficient of x will be x, and then x square by 4. Next bracket, the coefficient of x will be x by 2, and so on, and similarly other brackets. Now to get the coefficient of x, what we need to do, we need to multiply this 2x with the product of all the ones of the remaining brackets. So this will be 2 here. Then this x will be multiplied with ones of all the remaining brackets, so we will get 1 here. And similarly 1 by 2 and so on. This will go up to infinity. It is sum of actually infinite GP. We will get P1 to be 4. Now using this result in A option, we can find now P2, which will be 4 upon 2 power 2 is 4 minus 1 3, and here it will be 1 plus 4. So we will get here 5 into 4 20 by 3. Using this we can find P3. P3 will be 4 upon 7 into 4 plus 20 by 3. Okay, so 4 into 3 12, 12 plus 20, 12 plus 20 32, 32 into 4 128 upon 21. So this is the value of P3. Now if we have to find P4, this can also be found the same way. P4 will be 4 upon 15, and here we will be adding P3 and P2, P3 and P2. So 20 by 3 plus 128 by 21. Take 21 as LCM. So 140. Yeah, 140 plus 128. So that will be 268. So 15 into 21 is 315, and 4 into 268 is, I think, this 1072. 4 8s are 32, 4 6 are 24 plus 3 27. Yeah, so C is also the answer. Okay, now coming to the question, now coming to the teaser question. Dear all, if you are preparing for JEE Advanced or you plan to prepare, then Vedantu Olympiad is one big thing in online domain. If you know it already, it is fine. Otherwise, just Google it. I'm here sharing with you the notice board link where all important information regarding new batches coming up or new things going on in these batches will be shared. This is the QR code of the same thing. Just follow it. The students who are going to appear in JEE Advanced in 2023, please join the Telegram channel using this link or using this QR code. We will be putting all important informations regarding JEE Advanced 23 batch in that channel. Similarly, for 2024 aspirant students, this is the link and QR code. Please join that channel. Dear all, we have in V-Impact channel created solutions of JEE Advanced and KVPY as of now. Very soon we are going to upload solutions of ISI and CMI, and these solutions are question wise, and you will find alternate solutions also in that channel. So please go through it. You just scan this QR code to go to that channel. Now coming to this teaser question, I think it is little blurred, but I hope you will be able to understand it. Sn is k is equal to 0 to n minus 4 raised to the power k into n plus k c2k. Then find the value of S 2011 plus 2 times S 2010 plus S 2009. Okay, if you have solved it, please send your solution to this ID eklavyasupport@vedantu.com with the subject line teaser solution maths. We will check your solution, and if we like it, we will reach out to you on the same email ID through which you have sent the solution. So that is all for today. Thank you so much. Bye everyone.